Okay. Uh, in this session, I'm going to very briefly introduce the idea of programming. I'm going to focus on programming for DevOps. So we're not going to be learning to be, full-blown software developers, but we're going to learn enough for two purposes. One, in DevOps, you will write a lot of utility and glue scripts in particular, but sometimes programs. And yeah, so it's useful to know programming for those things. You will also invariably come across the product of developers, and of necessity, you'll need to be able to read their code. Now, obviously, taking DevOps to its sort of full meaning, developers will also be involved anyway. But the point is that for the role that I'm talking about, the DevOps engineer, you don't really need to know all of the intricacies that one would need to know as a software developer. So I'm gonna break this down into a number of sections. I consider this I consider programming in general to be one of three categories. Coding, which is the basic mechanics. So coding is really nothing more than being able to write in a particular language. So it's really a question of just instantiating some algorithm in that language. Programming is, if you like, the next step up from that. So with programming, you're taking a requirement and you are then working out the algorithm to fulfill that requirement, and you are then writing the code. Okay, so programming is sort of one step up from coding. Software engineering, and there's a lot of debate about that as a title nowadays. Whether we refer to it as software engineering or as craftsmanship. I would argue that it's actually a combination of craftsmanship and engineering. And I mean engineering in the sense of practically applied science, or the practical application of the scientific method. Software engineering is the entire process of requirement solicitation, interpreting those requirements, devising systems to fulfill those requirements, providing all of the infrastructure and facilities to do that. So software engineering is the entire piece, okay, and sits therefore above programming. We're going to take it to somewhere between programming and software engineering. So we're going to fit somewhere in between those two. And the reason I say that is because traditionally, I don't think programming has done a very good job of I don't think classrooms have done a very good job of teaching programming for the non-programming roles, as it were. People are being left to their own devices, and they kind of like just have to muddle through. So we're going to approach this from a more software engineering perspective, but we're going to do it with bearing in mind that we're really talking about the DevOps kind of level of requirement. Okay, I'm going to use, in these examples, I'm going to use three languages. Two of them I don't think are particularly controversial in terms of a choice of language to teach for DevOps. So we're going to use some Bash scripting, and we're going to do some Python. The third language is a bit more contentious, and I'm going to use Lua for two reasons. First of all, Lua is a very widely used embedded language. If any of you choose to use the NeoVim text editor, then Lua is now a core part of that. So if you want to customize your text editor, Lua would be the language to use. But Lua is often embedded into other systems as well. I mean, even things like video editors and stuff like that now will have Lua programming embedded, often alongside things like Python, in order to be able to extend them. So Lua is worth learning. It's also a very simple language in that it really only has sort of one complex type of data. Got very simple commands and structures. And that was all done deliberately for two reasons. One, speed, but also the fact that it was really intended as a sort of micro language, precisely to be embedded in other systems. So we're going to learn those three languages. Now, the problem with learning those three languages is that they're all what are called dynamically typed languages. We'll get on to typing, not as in, but typing as in data typing. So we may, at a later date, look at things like Java, C, Rust, Go, because they're all hard type languages, and they have their own complexities and subtleties, and there's a good reason for going both ways. And when we learn Python, we will learn a typed Python rather than untyped, but we'll get there eventually. Okay, so I promised that this was going to be programming for the absolute beginner. So I'm afraid for those of you that have had any familiarity with programming, this first section is going to be very tedious because we're really just going to be doing the very basics of coding for our first section. Okay, so if you've set up your machine, as I have done here, according to the instructions, what you should be able to do is SSH into that machine, and you'll see that we've got three directories: Bash, Lua, and Python, and that is, if you want to set this up and make sure you're in the same place, you should be, because this should have been set up automatically. Okay, so you set up for exercise 1.1, and what we should now have is, if we cd into Bash, okay, you should see that we've got a spec directory, and I'm basically going to be walking through this, which is the book I'm currently writing, Programming from Scratch. Here we go. So we're going to start from here. Now, what I'm doing is I'm starting you off with some ready-made requirements. Okay, so the first thing we're going to run is a program called shell spec. Okay, which is, whoops, try that again, but in the correct screen. So we're going to do shell spec. Okay, and what that will do is run the tests which exist within that spec directory. You don't need to worry about the details of this, and although this looks scary, it's not that big a deal. Okay, in fact, it tells you exactly what's going on. Okay, so what shell spec does is it runs the tests, and each test is numbered, and we get a piece of text that says what the test is for. Okay, so convert shows greeting. Convert is the, so it says when we run the script bin/convert, Okay, the output should equal hello world. So we were expecting hello world and we got nothing. Okay, and then we get 1.2, which is the second output from this test. Okay, it exited with status non-zero, but not found expectation. Again, you don't need to worry too much about that. There was output to standard error, but not found expectation. Don't need to worry. Okay, this is the really important bit. Cannot open bin convert no such file. In other words, we haven't written it yet, so we can't really expect you to do anything. Okay, so the very first thing we're going to do is we're going to actually create this program. Okay, so the first thing we do is we make a directory because we're expecting, it's expecting it to be in this bin directory. Okay, so bin. Okay, and it's expecting a file called convert. Okay, so we will create the file bin/convert. Oops. Convert. Okay, and I'm just going to make my life a bit easier by making it, by making it +x, which means it's going to be executable without me having to explicitly specify the shell. So let's go to that file. Okay, and that file currently is, as we see, completely empty. Now we're going to cover some of the subtleties of writing these scripts, but at the moment, what we're going to do is the simplest possible solution for the task we've been given, which is to just print out hello world. Okay, exclamation mark, and close the quotes. Okay. So what have we done? Well, echo is just going to display the following text on the console. Okay, so that's our program, and now we can rerun our shell spec. Okay, and you can see this time we're running one example, no failures, we've satisfied the goal. Okay, so in this case, okay, it's a very, very simple program. Echo, which just means print to the console, and then the string hello world, and that's what we expected. Okay, so you can see here the first test expected hello world. We've now written a test to satisfy that. So far, so simple. Let's do Python next. Okay, so with Python, you'll see that we've got a bit more complexity. Don't worry about the details. I'll explain all of this once we get into setting up a Python project. But we've got some tests in the test directory, which means we can do this poetry. Poetry is just a program that helps to set up an environment for executing Python and Python tools. And the tool we're going to run is called PyTest. Okay, so you can see here we've got one test which is failing, and the test is failing because it's attempting to import something called convert, and it says there's no module named convert, so we get a failure. So this is the equivalent in Python of what we just saw with the bash script. Because we haven't written anything yet, we're not going to get any output. And I think, yeah, I actually order in the book. Okay, so we're getting this out. So now what we need to do is we need to actually write the Python equivalent of this script. So vi convert.py. Okay, we put .py on the end to tell us it's a Python script. And this time we're going to use the print statement, which is the Python equivalent of echo. And we're going to print out the string hello world. So print is basically doing the same thing as echo. Okay, all it does is it takes everything between those brackets, which is the literal string hello world. Okay, so just a string of characters, and it displays it on the screen. Okay. In fact, we can show it actually running if we go to run Python. This is Python 3, but I think this system's set up so Python actually is already mapped Python 3. So you can see when we run the program convert.py through Python, we get hello world. When we do the same thing with the bash version, okay, if we run, okay, so we run .bin.convert, you can see we get the same output. Okay, so we've written our program. Does it now pass our tests? Yes, good. Okay, so we got one test and it passed. So we've gone from having a problem to solving the problem. Okay, we can show that we've actually solved the problem because if we go back to this and we say something like USA rather than world, and then we run the tests again, you see this time it says no. Although I've now found the convert program, you can see that here it's saying there was a test which basically checked whether you output hello world, and I was expecting hello world and I got hello USA. Okay, so we'll just go back and fix that. Okay, make sure our fix is written. And the reason I'm doing it this way is I want you to be certain that every time you do something to your code, you run the tests. Okay, this is a good habit. And this is something that you will encounter called test-driven development, where you write the tests. It's a terrible name. Test-driven development is really a bad name, but it's the one we're stuck with. It's really more requirements-driven development, but the difference is that we instantiate the requirements in code. So we actually write our requirements as automated tests. And as you'll see, as we go further and further into this, it becomes more and more useful. We'll cover in a moment how it becomes very useful very quickly. Okay, so just very quickly, let's go and do the same thing for Lua. Okay, so going back again to here. Okay, if we go to Hello World in Lua, you see this time we're using a system called Busted. Okay, and Busted is basically the same thing as shell check or PyTest. Okay, so if I run it, you can see this time though we get I ran this specification. I expected these things to be the same. I was expecting hello world, but what I got was the empty string. And the reason for that, because this program doesn't exist. Okay, you can see here, cannot open no such file or directory. Okay, so the test is telling us what the problem is in a fairly succinct way. Okay, so let's make directory bin, because again this one's expecting it in the bin. I'll explain the differences, but basically I've put these in the bin directory just to keep everything nice and tidy. You'll see when we start dealing with Python that there are all various ways of structuring it, but there's a fairly standard way. So let's okay, and this time we'll call it convert.lua. Okay, now then, this looks pretty much identical to the Python version. Okay, and this is, again, this is one of the reasons I want to show you the different languages all at the same time, because it might be a bit confusing. But what I want you to take away from this is that the languages, although they're all different syntactically, in other words, they use different, they use different statement separators, they use different formatting, they use different commands. Like, for example, Bash uses echo, whereas Lua and Python use print. But, you know, that's the easy stuff to learn. All you need to do is learn the new commands, as it were, to do these things. The principles, however, are basically the same. Right, so we've now got our script. So let's run our tests. So we've been busted, and we get 1 success, 0 failures. Excellent. Okay, so we've now got 3 scripts, 1 written in Lua, 1 written in Bash, and 1 written in Python. And they don't actually look that different. Okay, so if we go to the Bash, in convert, you see that one is just echo hello world. We've got the Lua version, which is just print hello world. And we've got the Python version, which is print hello world. Looks pretty much the same. Right. The next thing we want to talk about is variables. Let's do this in the same, let's do this in the same order as I've got them on. Okay. That double underscore PyCache, by the way, is a directory created by Python. Python is it's an interpreted and a compiled language. PyCache is a semi-compiled version of the system of the Python code. Okay, so you write the Python source code, and when you run it, it gets sort of partially compiled into bytecode. And this is fairly common with things like, Java does much the same thing. And the idea behind it is that it makes it easier to make Python transportable between platforms. But we don't need to worry about that at the moment. We're just learning the basic mechanics. Okay. So what we're going to do now is we're going to replace the literal string, the actual string in those print commands, with a variable. Okay, so this string here, oops. Actually, I might as well rid of that. Okay, and we're going to call it, what do I call it? Greeting message. Okay, and we're going to assign that to a variable. And then in this print statement, we will just use okay. So what we've done here, we're using this greeting message as a sort of placeholder. Okay, so a variable is just a name that we give to some piece of data. So this thing, this thing here is called a literal string, and it is a piece of data. Okay, it's just literally everything between those double quotes is the thing that we want to call the piece of data. And we're assigning that to the greeting message, which is just a variable. And here we are using that variable. Okay, so all we are doing here is we're saying we're removing it one step. Okay, so we're saying, okay, we've got this thing called greeting message. We're going to give it a name, and we're going to then use it by that name. Now, the great thing is, because we've got that test, we can see whether or not we've broken it. So we can say poetry run PyTest. Our test still passes. So we haven't violated the basic requirement. Okay, the basic requirement was a program that prints hello world to the screen. So although we've changed our code, we haven't violated our requirements. Okay, it still passes the tests. And this is why these tests are useful. What we have just done is a process called refactoring. Okay, refactoring is simply taking a piece of existing code and improving it in some way. Okay, and we've improved it. We've improved it by taking the literal string out of the code and making it a variable. Why that's an improvement we'll get to when we talk about programming. But the point is we can make modifications to our system and then we can rerun the tests and make sure that we haven't damaged the system in any way by making the changes we've made. As you get more and more sophisticated in your programs and you get more and more tests, these become more and more important to the process of refactoring. They make sure that we stay within the guide rails. Okay, so you can think of the tests as setting the boundaries of what is acceptable for our system. Anything between those boundaries is fine. We can write any code we'd like to satisfy as long as we stay within the lines. Was it Lua I did next? Yes, I did Lua variable. That's good. Okay, so this is Lua variables. And you'll see that it's pretty much the same. Okay, so that is almost, well, it is basically identical. Okay, so far, Lua and Python look to be the same. They're not, but they look like it. And this comes to my point I made earlier. Okay, so it basically looks the same because we're doing the same thing, and the syntax so far is very similar. Okay, so we can do Lua. And we still get our success, which means we haven't broken our Lua code. Okay, so now we can go and look at bash variables. Now we get into a world of pain. Not really, but it's just a little bit more complicated with bash. Okay, so what we're going to do here is we're going to assign to a variable. So far, it looks the same. Okay, now when it comes to doing the echo command, now this is going to be slightly different. Before, we just had the literal string here in the echo command, and you'll notice that the other commands had print with brackets, okay, and then the string or the variable. Now, what we can't do is we can't just name the variable like this. Okay, because if we do that, it won't work, because what it will print out is greeting message. Okay, so if I run this now, you'll see it outputs greeting message, not the contents of the variable. And so okay, we get this error. Okay, so we were expecting the hello world string and we actually got greeting message string. So why is that the case? Well, it's because of the way Bash works. When you define a variable, you just give it its name. Okay, when you use the variable, you need to put a dollar in front of it. Okay, so now I get the contents of the variable. And if I run shell spec, it will pass. However, there are complexities with shell. Okay, so although that works, it's not the way I would recommend writing this. Okay, what I would recommend is I would recommend you, first of all, that you put quotes around it, double quotes. It has to be double quotes. You put single quotes around it, you'll get literally dollar greeting message. Double quotes allows the shell to expand the variable. Now, the other thing you really should get in the habit of is curly braces. Okay, so although this looks frighteningly complicated, and it's not that bad. Okay, what we're doing is we're defining the variable up here. Okay, so we define the variable here, and then we use it here. Okay. Now, when we use the variable, you saw we could just put dollar greeting message, but there's a problem with using it like that. Okay, well, there are several problems. The first problem is this. Let's say I wanted to output the message hello world, okay, and I didn't want the greeting message to contain the exclamation point. That's not a really good example, is it? Let's say I wanted to put an X out after this variable, okay? If I put the X out now, like that, okay, and I just run this, I get hello world X, which is exactly what I expect. However, if I used this form, you can see the problem. Okay, because without the curly braces around it, what I've now got is a variable called greeting underscore message X. Okay, and what we will get now is nothing. Okay, we just get the new line character because the variable greeting message X doesn't exist, it has no value, therefore it produces nothing. So that's the problem we have with that. And the same thing goes with the quote. Well, the quotes are a bit more complicated. Okay, to explain the quotes, we're going to have to dive into a bit of bash. Actually, yeah, I better. Okay, let's get rid of the quotes. And the curly brace. And what we're going to do this time is we're going to say, give this the value star. Okay. Okay, so now what we're doing is we're echoing out the star variable. Get bin and spec. Where did they come from? Well, if you look at the directory, that's the content of the directory, bin and spec. So what's happening? And this is a source of a lot of bugs within shell scripts. Okay. What's happening here is when we do this echo, this dollar greeting message, okay, gets expanded, and it gets expanded to the asterisk or the star character. Okay, so what this really says is that. Okay, so it says echo asterisk, but we're not finished. Within bash scripts, or indeed on the bash command line, if you put a star, the shell will expand that to a list of the current directory files and directories. Okay, so because our current directory contains two directories, bin and spec, because that's where we executed it from, we now get this expanding out to be something like execute bin spec. Okay, and now because we've got no expansion left to do, that's what actually gets executed. So we get echo bin spec. Okay. So to avoid all of that problem, okay, we put quotes around. Okay, the quotes actually do well. Actually, I can do this. Echo, oops, this. Okay, now what you'll see, yeah, now we get the star. Why is that? Because stars, any of the expansion characters, I won't go through them all. Okay, any of the expansion characters do not get expanded if they are in a string. Well, hang on a minute, you might say, this is in a string. Yes, but as soon as the variable is expanded, it's what's between the quotes which actually gets printed by the variable. So it's the star that gets output. Yeah? So the quotes around it don't actually get output, which is why, oops, which is why I need to do that, put the quotes around it like this. Okay, I can do that. Okay, so now that gets expanded to echo quotes star quotes because the star is the value that's held in greeting message. Okay, when I run that, I now get the star out. Okay, and recall what we really want is to do this. Now, you might make the argument, might just fix this while we're here. Okay, you might make the argument, but I don't need to do that every time, do I? I mean, if I know what's in greeting message, then I don't need to put the quotes around it. I don't need to put the curly braces and so on. And the answer to that is technically no. I mean, in this particular instance, no, we don't. Okay, because we know that the string hello world won't expand. It's got no stars in it and things. So we know it won't expand that way. We know we're not following it immediately by some other character. So we don't need to put the curly braces around it. So technically, we could just put $greeting message as we saw. And it will work. My point here is that this is part of what we call defensive programming. That is, we program in such a way to minimize errors later down the road. And because you can make the mistake of having greeting message contain, for example, a star character, by putting it inside quotes, you eliminate that problem because the star won't be expanded. Because we might make the mistake of actually, we might, for example, we might be joining these strings together, or we might be have another variable immediately following it, or something like that. But we might have a character at some point after that, which will cause it to be the wrong variable name. It's best to put the curly quotes around it. Sorry, the curly braces. So it's just a question of, do you want to type 3 extra characters or 4 extra characters, or do you want to spend hours trying to figure out a really subtle bug? I know which one I prefer. Okay, so we can run shell spec now, and we pass. So the script as it now stands is fine. Okay, it does the job. So You see the three different versions. Okay. So we can see here that the bash one is becoming much more different, and the convert, the Lua and Python are essentially the same. Okay. By the way, if you want to read about all of this stuff about globbing, word splitting, all that kind of stuff, it's all in this page of the book. Okay, special variable. Right. Now then, for this one, we're going to step things up a bit. Okay. Oops. So we'll go back to our root directory, although I don't think it actually matters. And we're going to update our exercise to 0.1.02. Okay, so that this has just updated the tests basically. So where did I start? Did I start with? Yes, I did. Started with the bash one. Right. Okay, so we're going to bash. Okay, and we do shell spec. Okay, and now we've got a problem. So we've now got two tests being run. Okay, the first one, convert shows greeting number 1, and convert shows greeting 2. These are just the names of the test. Okay, this is what we're expecting. When we run the script bin convert with nothing after it, we expect the output hello space exclamation point. What we got was hello world, which is to be expected. That's what we left the script doing. When we run the script bin convert mark, we expect it to say hello mark exclamation point. But what we got was hello world exclamation point. So what are we saying here? Well, it should be fairly apparent that whatever we provide after the convert program is invoked, whatever the argument on the command line is what we want to be printed out. So let's have a look at our convert script. Now we've got a variable in there. What we want to do now is we want to be able to replace this world with something else. Okay, so let's say we want to replace it with another variable. Okay, so we will replace it with $, curly brace, say name. Okay, so we're following our convention, $ curly brace variable, and the variable is name. Now name doesn't have a value at the moment, so we need to give it one. Now we need to put it before the greeting message because we need to assign it a value before we use it. Okay, and what we're going to do is we're going to use special variables in bash called positional variables, and these are, now I'm gonna tell a lie here. Okay, these are the parameters passed in on the command line. Okay, and we give them a number. So the first argument passed on the command line is $1. The second is $2. The third $3, and so on. That's a bit of a simplification, but it'll do for now. So what I'm going to do is I'm going to say, give my name, okay, the value of the positional variable 1. I'm going to slip with my fingers tonight. Okay, so I'm following the same convention. Okay, we could have just written $1. Okay, and I often do. I've got to admit, I'm pretty lazy when it comes to this type of thing where I'm just assigning it to a variable. Okay, but let's be strict. Look, why am I relaxed about it doing that? Well, because I'm lazy. What can I tell you? This is the correct way of doing it. Oops. Okay. So now we're saying take the positional variable. We don't have to worry about assigning a value to $1 because it's whatever the first string after the convert command, okay, the convert program name, first string after it will be assigned to $1 in this program. It is a special variable, a magic variable if you like. Okay, so if I run bin convert, okay, and I type world, then you know what's going to happen. We're going to get hello world. Okay, if I type mark, I get hello mark. Now then, what if I type hello mark world? What will I get? Well, on the command line, okay, mark and world are two separate, they're space separated arguments which are being given to the script. Okay, so in actual fact, mark will be assigned to 1, world will be assigned to $2. Okay, so all we will see is hello mark. If, however, I put this in quotes, okay, I have now said mark world is a string. It's in quotes. It's the first argument. So $1 will be now mark world. Okay, so when I run this, hello mark world. Okay, so you can see how, yeah, $1 is the first string on the line. Okay, and shell script thinks of these as two strings. I have to put quotes around it to force it to be one string. And that's pertinent to our conversation earlier about why you should always put quotes around variable expansions. It's for this kind of reason. Okay, so if I now run this shell spec, wonderful. Okay, my script now works. Why does it work? Well, if we look at the tests, if we run the script bin convert with nothing after it, I expect to get hello exclamation point. Okay, if I do that, because $1 is effectively empty, I get hello exclamation point. If I run bin convert with mark after it, we've already done that experiment here, and I get hello mark exclamation point. Okay, and that's what I expect to get. So my specification has been met, my tests pass. Excellent. Okay, going back to our book. Command line in Lua. Okay, so if I go to Lua, I run busted, I run my tests, and what do I find? I find I've got failures. Why have I got failures? Okay, so they're both the same test. Convert shows greeting, but in the first test, I got hello world when I was expecting hello nothing. Okay, and in the second test, I got hello world and I was expecting hello mark. Now this isn't quite as informative as the busted tests, and I would probably have to look at the tests to work out what it was doing, but we're not going to bother because we know what we're doing. I'm going to change this. Okay, and in the same way as we did before, we're looking for replacing world, okay, with a name. Now, there are several ways of doing this. We are going to do it this way for now. So we're going to say hello world, 2 dots, then the variable name, and then 2 dots. Oops, didn't mean to do that. That's what I meant to do is insert. Okay, so what's this doing? Oh, sorry. Oops. Okay, so, and then the exclamation point. So what's this doing? Well, these dots are what are called concatenation. So this is saying the greeting message is a string consisting of 3 parts. First, give me hello, then give me whatever the variable name says, then give me an exclamation point. Okay. Oops. I've actually, this will be a good teaching point. So I won't correct it. There is a mistake in this program, but first of all, let's deal with this. We need to give name a value. Okay, and the value we're going to give it is another magic variable. Just as we had positional arguments in bash scripts, we've got a very similar kind of thing in Lua. Okay, in Lua, there is a magic variable called arg, okay, which is always contains the arguments on the command line. Okay, and 1, much like in bash scripts, is the first string on the command line. Now, let's see if our tests pass now. And the answer is no, they don't. Why not? Well, you can see down here, it's more obvious. Hello, Mark, there's no space. Okay, so I have not yet met the criteria. Okay, and the reason is, as I said, there was a mistake in the script. I needed to put a space here. Okay, now I could have done this. I could have done the more long-winded way. Oops. Okay, that seems a bit unnecessary to me. Okay, I could have done hello, then the space, then the name, and then the exclamation point, but it seems a bit redundant when I can just put the hello after the name. Okay, so now if I run this, wonderful, it now works. Okay, now does exactly what I expected. Okay, on to Python. Okay, and if you remember, with Python, we run it through poetry. And we use PyTest. And you can see we've collected 2 tests. And we've got the problem again. We get hello world, and we were expecting hello. Okay. We were expecting hello Mark, and we got hello world. And that's because we haven't changed our code yet. Again, you don't need to worry about reading these at the moment. When we get onto programming, I'll teach you how to read the tests as well. But for now, convert.py. Right. So we need to do the same thing again. Right. Oh, you can see here I've done some extra magic actually. Let's cover that while we're at it. Okay. So PyTest, and then we used TV equals no, and then V to make it more verbose. Okay. So what have we done here? Well, we've done 2 things. The first thing we've done is we've made it a bit more concise because we don't get all of this assertion stuff out. All we get is, okay, we want the welcome message hello nothing. If we input nothing, oops, that's before this dash. If we input Mark, then we expect to get hello Mark with a new line. we input nothing, we get hello space. Okay, and this is telling us that that's not what we're getting, so we're getting a failure. Okay, so that was just, it's just a different way of displaying. So again, we will cover in more detail all the PySys stuff. For now, what we're really interested in is getting the command line in here. Now it gets a bit more complicated with Python. So the first thing is to get the variable into Python, we actually use a thing called formatted strings. Okay, so tell it that it's a formatted string, we put an F in front of it. Okay, and that means we can now do things like this. All right, so now the greeting message is a formatted string that it is made up of hello. Oops, made up of hello, followed by a space, and then these brackets, and this is the magic of the formatted string. Everything in between those curly braces is treated by Python as a small piece of Python code, which is executed, and whatever the result of that is, will be placed in the string. Now, because in this case, all we're doing is mentioning a variable, and this is the most common thing to do. Because we've just mentioned the variable, okay, what happens is that variable is evaluated. And when it's evaluated, of course, the value it gets is whatever value is assigned to that variable, and that gets plugged into the string in this position. Okay, so just as before, we now need to get name assigned whatever the first argument on the command line is. And this is where it gets a bit more complicated. Python, by default, does not have any magic variables. But what it does have is sysargv. Oops. Okay, so whereas in Lua we had args, in Python we have argv for arg variable, okay, which is an array. It's a list of stuff just like in Lua, okay. And again, the first one is the first string on the line, second one is the second string on the line, and so on. So what's this sys? This sys is a piece of magic which we're going to use a lot. Okay, these are libraries. Okay, and in order to use a library, we need to use the import. Now, where on earth do you find out about libraries? Well, this is sort of the magic of all. You can go to docs.python.org, okay, and this gives you all the documentation about the standard Python and the standard Python libraries. So it's worth going and having a look at the Python tutorial, okay, which will teach you all the stuff that we're learning tonight, and a lot more. The point being that you can also do things like you can look up, for example, if we do a search for argv, okay, you can see here there's loads and loads of stuff. A lot of it will be completely meaningless without knowing what's going on. Okay, but we can go to, for example, sys, system specific parameters and functions. Sys.argv is the list of command line I pass to the script. There you go. Okay. So you can find pretty much anything. It's not the simplest thing in the world, but it's also available. Okay, so it's worth investigating. Same thing goes for Lua. Okay, in lua.org you will find that there is a page which describes the language and what you can do with it. And if you want bash, it's at gnu.org/software/bash/manual. Okay? And that's got the complete manual of, so you can look stuff up for yourself. Okay, so back to our example. So Python's a little bit more complicated. Okay, with Python, we have to get the sys library, bring that into our script. We then use the sys library to get access to the argv variable. We'll explain this later, but basically this says use sys. In sys, we're looking for argv. It's an array, and we want the first element. It's actually the element at index 1, because the first, well, Python arrays are indexed from 0, but again, we'll get onto that. Okay, all you need to know really is it's the first string on the command line after the command, argv, assign it a name, and then we assign greeting message with a formatted string, f, okay, and that's hello space, whatever name evaluates to. And the rest of it is the same as it was before. Okay, so now if we run our tests, that's it. We've got 2 passes. Okay, so it means that we've now satisfied our requirement. Okay, quick review. What have we learned so far? Okay, we've learned about a basic statement to print something onto the screen. We've learned about variables and the fact that they hold values. Okay, there's a lot more to be discussed about those, but that in essence is what we've done. We've learned that there are some magic variables which are provided by the system. Things like positional variables in bash, yeah, $1, $2. We've learned that Lua has a very similar thing in the args variable, args1, args2. Okay, and we've learned that Python, we need to access a library called sys, and in there is an argv which gives us the same thing, argv1, argv2, and so on. Okay, let's go back to our book. Okay. And now we're on to functions. Okay. Parameters and arguments, these are used a bit loosely, but here are the correct definitions. When you define a function, you can, okay. When you define a function, okay, you can give, you can specify parameters. It's a bit different in Bash, okay, but in Lua and in Python, you can explicitly give them names. So in this case, add has 2 parameters, A and B. Okay, so parameters are the things that you define when you define the function. Arguments are what you provide that get mapped to those parameters. Okay, so here, for example, okay, we are defining the add function. It's going to have 2 parameters, A and B. It's then going to add those 2 parameters together. So it's going to add A to B, and it will return the result. So when we call add, we give it 2 arguments, 1 and 2. So argument 1 will get mapped to A, the first parameter. The argument 2 will get mapped to B, the second parameter. You're not making this easy, Kenny. Okay. So, just a quick step back. What is function? Okay, a function is an abstraction. what's an abstraction? An abstraction is any time that you simplify access to some function, and I mean function in the general sense. Let's give an example. Okay, on your television, okay, there is, assuming you're not using actually a remote control as good as any, okay, there's a little rocker switch for up and down volume. Now there's a whole load of complexity that's being hidden by that button. When you press that button, it's making a circuit in the handset, which is then sending a signal via infrared or radio, depending on the type of handset, which is then being picked up by a receiver in the TV, being interpreted as, oh, I want you to turn up the volume, then being passed on to a small computer, which then turns up the volume on your TV. All of that complexity is irrelevant to the idea of turn up the volume. Okay, that's all summarized in the simple interface, the button, turn up the volume. That's an abstraction. Okay. Abstractions are universally invaluable. We use them all the time. Okay. They don't just apply in tools. They don't even just apply in programming. They apply to all sorts of things. For example, a retail shop, in a manner of speaking, is an abstraction. Okay, it's an abstraction of a complete supply chain of warehouses and manufacturing that ultimately ends up with me being able to walk into that shop and say, I would like to exchange these pieces of paper for my new TV. Okay. The interface for me is extremely simple. I'm just doing a simple exchange. Okay, but the complexity that has had to go into that exchange before I even walk in the shop is huge. Okay, but I don't care about that because all I care about is buying my TV. That's an abstraction. Functions are the simplest form of abstraction. Actually, to be fair, programming languages are an abstraction. Okay? Programming languages are things like Python, for example, are almost English-like. Okay, you can almost read them like text, as in prose. But what they hide is a huge amount of complexity, because what the computer understands is small electrical signals, on or off. So the first level of abstraction for human beings is we think of that as binary, ones and zeros, but computers don't work on ones and zeros. They work on electrical signal present or electrical signal absent. So that's an abstraction. Yeah. When we talk about computers working on binary, that's an abstraction. Okay. That binary was then, the very early computers, you flip switches, ones and zeros, and you then clicked another one, which put that into the memory, and then you clicked a load of ones and zeros, and you flipped another switch, and that put that into memory, and that was how you programmed them. That was almost no. I mean, there was an abstraction there. Obviously, the switches representing ones and zeros, but there was almost no abstraction. It was almost directly talking to the hardware. The next level was people said, well, this is terrible, flipping all these bits. What if we did a hexadecimal keypad, which would allow us to type hexadecimal characters, each character representing 4 of those switches? Brilliant. Okay, that simplified things a lot, because now you could program in hexadecimal, okay, and you could write your program in hexadecimal. Then the next step up from that was people said, well, it's very error prone typing all these hexadecimal numbers in. What if we gave the instructions to the computer sensible names, and then we wrote a program that would take those sensible names and turn them into the hexadecimal? Another layer of abstraction. That's assembler. Then people said, well, this assembler stuff, we're having to repeatedly do the same steps over and over again. There's a lot of commonality, there's a lot of complexity. It's tedious telling the computer every single sort of step of the operation. So we got things like C, the programming language. C is an abstraction over the assembly language. It does a lot more. Compilers do a lot of work. If you look at compilers, the way compilers work, they do a lot more than you think. But basically, the compiler offers another level of abstraction. So you end up with languages like Python and Lua and Bash. They're all abstractions over a huge amount of complexity that you don't need to know. For example, I have only the vaguest idea how text is displayed on the screen. I'm talking about the engineering, the physical process. I don't need to. Okay, I've got this wonderful abstraction called Echo, which just types text on the screen. I don't need to think about the fact that Echo is having to talk to the operating system, and the operating system is managing the hardware, and the hardware is going through these drivers, and these drivers are talking to the electronics, and the electronics is then putting that up on the screen. I don't need to know about all of that complexity. I can use the higher level abstraction of the command Echo. And this is something we have to acknowledge, and something that I think a lot of people forget. Okay, you see people sort of talk about things, and they say, "Oh, well, we don't need to know all of that stuff." And it's certainly true. Now, when I drive my car, I don't need to know how an internal combustion engine works. It's useless if you do, because if you break down, you've got to fight in repairing it. Although nowadays, with the complexities they keep putting into cars, that's less and less the case. And the same thing goes for computers. It used to be a big advantage to know assembler because compilers in the beginning were not that great. And sometimes you would hit a situation where, in actual fact, writing a bit of assembler was a good idea because you could really speed up their code. But over the years, compilers have outstripped the human capacity to solve certain problems. And so it's very rare nowadays that you would need to write a piece of assembly code to solve a problem in a compiled language. Is assembly code still needed? Yeah, absolutely. There are still cases where assembly code is required, but that is becoming a more specialized area. By the way, machine code is actually an abstraction as well, because there's microcode which runs within the central processing unit, but that's a whole other conversation. And also a fairly recent sort of development. Well, recent in the grand scheme of things. So what's my point? My point is this: as time's gone by, even over my relatively short career of 30 odd, 35 years, 30, no, I don't know, something like that. Actually, 30, 35, yeah, 35 years profession. Oh, getting old. Even over my relatively short career, the necessity of knowing about the underlying, the underlying systems, the systems underlying the abstractions, has become less and less important. But having a broad understanding, as a DevOps engineer, really helps. It's really important. And the reason for that is you're often diagnosing some fairly complex problems. And unless you understand the basics of how the operating system you're working with, unless you understand the basics of the environment in which you're working, you will often find it difficult to diagnose a problem. Anyway, that's a slight aside. Yes, so functions. Functions are, as I said, the first level of abstraction. What they allow me to do is take a whole series of statements that implement some algorithm and give that series of statements a concise name. Okay, so in this example here, the concise name I've given it is add, and all it does is add two numbers together. Well, arguably not very helpful, because most people understand that a plus b means add a together. But as we'll see, functions can go a lot further than that. You could have a function that's actually a good case in point. We've seen functions already. Okay, in Lua and in Python, the print statement, or the print, is actually a function. Okay, so print, open brackets, some value, close brackets, print that value to the screen. Okay, so print is a function. Okay, and its sole purpose is to output a string of characters to the screen or the console. Okay, so again, it's an abstraction. It overlays a whole load of complexity that I don't know about and I don't care about in principle. What we're doing now is we're defining our own functions, okay? And in order to do that, we need to understand parameters and arguments. Okay. So what we're going to do now is we're going to take our print statement and we're going to put it inside a function. Okay, so we'll start with our Python. Okay, so what we're going to do is this stuff is all going to remain the same. Okay, but what I'm going to do is over and above this, I'm going to define a function by saying def, and I'm going to give it a name. Okay, and that name will be display. I think it's greeting. Okay, so display greeting, and then I'm going to say greeting. Okay, and then and this is part of Python's charm. Okay, you indent. So you put a colon at the end of your define statement, which says that's the thing I'm defining, and then to say which statements are included in that definition, you indent them. Okay, now we don't want to print greeting message anymore. Okay, we just want to print greeting. Okay, so now what we're saying is just print whatever is supplied as the argument to our function display greeting. Okay, so how then do we invoke it? Well, we mention it by name. Okay, and now we give it the argument. The argument is okay. Okay, so what have we got here? Well, we're defining a function and we're giving it the name display greeting. Okay, and we're saying that this display greeting function has got one parameter, which we're going to call greeting. And then by indenting these lines, we're saying, well, okay, what this function does is, and it just does one thing, which is it prints whatever value is supplied to the parameter greeting. And the first thing we do or the last thing we do in our program is we call this display greeting and we give it the greeting message which we constructed. Okay. If we run the Python tests, which by the way we're passing, remember. So what are we doing? We are refactoring. Okay, our tests are still passing. So although we've done some quite substantial changes to the way our code's laid out, what we haven't done is changed the way it works, which is good. what we want. Okay, the next thing I do is I demonstrate. So now what we're going to do is this greeting message up here, okay? What we really want to do is we want to say, okay, I want to compose a greeting, okay? So I'm going to define another function called compose greeting. Okay, and compose greeting is going to have one parameter, which is the name which we want to put into the compose greeting. Okay, and all we're going to do is we're going to return the string hello name. Now we've got an interesting situation. Okay, because what we've now got, actually before I do anything, I will call compose, I will say that greeting message is to equal whatever I get back from compose greeting. Okay, and I'm going to pass it name. Now then, we've got some quite subtle things here. Okay, but before I go into that, let's just make sure that we've not broken anything. Excellent. Our test still passed. Right, now then, let's talk about a few subtle things here. Okay, first of all, this name is not this name. Okay. This name is a variable defined at the global level. In other words, it's defined at the top level of the program. Okay. This name refers to this top level name. Okay, and is passed as the argument to the compose greeting function, and is then assigned to the parameter name. So this name is actually the parameter name. Now this is called scoping. Okay, let's talk about scoping. Your program has a global scope. Okay, now anything within this box can see that global scope. The functions, so compose greeting is a function, and it defines its own scope. Okay, and when it defines a parameter name, this name is visible inside that scope. And because this name, okay, this name here, because this name is also has a name up here, okay, it will shadow it, it will hide it. Okay, so if I call name in here, I'm talking about the name in this local scope, the scope of the function. Okay, let's just do a quick demonstration. So to demonstrate this, what I'm going to do is instead of passing name in here, okay, oops, what I'm going to do is I'm going to pass in our old friend world. Okay. So if I now run that, if I run convert pi and I pass in mark as my variable, okay, what I actually get out is hello world. So, yeah. Okay, so what's happening? This name is being given the first argument, which is mark. Okay? So, but when I call composed greeting, I'm actually giving it the argument of the string world. So this name has been assigned world. Okay, so within the function, within the composed greeting function, this name refers to this name. Okay, so I get hello world out. Okay, let's do something else. Okay. Now, instead of calling this name, let's call it namey. Doesn't matter what. Okay. Okay, so now we run it and I get hello mark. Right? And the reason is okay, the reason is this. Now this variable is not called name, it's now called name capital Y. So this is being given the value mark. Okay. So this name here now refers to the global scope. Why? Remember, everything inside this global box, okay, can see this variable name. Okay, the only reason we couldn't see variable name before was because this variable was called name and therefore shadowed it. Okay, so anything inside here that referred to name, okay, would see this name. Now that this variable is called name capital Y, but this is still called name, we will see this name. And that's the beauty of scope. It's also a very common trap. Oops. Okay, so to go through that again, name is assigned the first argument, okay, and I put mark. So when this function is invoked here, world is assigned the variable name y, but in here I'm referring whatever the variable name is. Well, that's still what was originally assigned, so mark. So it would say hello mark rather than hello world. Okay. If this is called name, then what happens is this name will shadow this name. So this name will now take this value rather than the global variable name. Okay, so confusing though that may seem, it's actually very straightforward. At the point that this is invoked, this name is the global name. Therefore, it takes on whatever argument has been passed in. Okay, but that value is then passed as the argument into this function and assigned to this name parameter. So by the time it gets to here, this name is whatever this value is. and it therefore returns the string. Okay. Okay, now we can go one step further. Okay, and without going too specific into what Python does, okay, we can take one step further. Okay, and one thing we can do is we can say define main. Okay. Main takes the command line arguments as a parameter. Okay. Now we can bring this down. Oops. We can take the next 3 lines and here we're going to say, now this is not by any means good code. I'm just using all of this stuff to just illustrate a point. This command line okay. But all I've done now is I've taken everything out of the global scope. Okay, so all of this stuff now is all local scope. Okay, now like I said, this is not good Python by any stretch of the imagination. And there's a lot of work to be done that we'll cover when we discuss programming. And I think it's the difference we make between good and bad programs. So what have I done? I've defined another function called main as one parameter called command line arguments, which, as you can see, just takes the sys.argv when I invoke it, and everything else that was global is now local to here. Okay, so name and greeting message are both now local to main. Name simply extracts the first command line argument. Greeting message is prepared by calling compose greeting. Okay, and now this name is not the global one anymore. It's actually this one here, the local one. Okay, but again, this name is not the same as this name for the same reasons. They're in different scopes. The only difference now is that, whoops, the difference now is that okay, so what we've got now in the global scope, we've got just the functions. Okay, so we've got 3 functions in the global scope. But the ones that are important now are the compose greeting, okay, which just says the name. Yeah, this name is local to this scope, and main, okay, it has a name which has been defined inside its scope. Okay, So this name is only relevant within this scope. Okay? But at the point when we call the compose greeting, when we put name in there, it's this name which gets put in here. Okay, but having invoked this, it's now this name as the value inside the local scope greeting. And that's it. It's as simple as that. Whoops, and I've just realized I did all of that without showing it. So let's just quickly run through that again. Okay, so in the global scope, we've got two functions. We've got compose greeting and main. We've also got the third display greeting. Yeah, that's irrelevant for what we're talking about. So at the point here, name is declared, okay, as local to this scope here. Okay, so it's local to the main function. Okay, so that name doesn't exist outside of that function. When we invoke compose greeting, this name is actually the one within the scope of main. But at the point we enter the compose greeting function, this parameter has now been assigned that value. And so inside this scope, it's actually the value assigned to this parameter. Right. Oh, on the code, what we've got is this name only exists within the scope of the main function. So when I call compose greeting, it's that name which I'm going to see. Okay, so whatever value is assigned to that name will be passed as the argument to compose greeting. And it will be assigned to this name parameter, which will then be put in here. And this name parameter is local to the compose greeting. Hopefully that makes sense. Okay, so that's functions. So let's just make sure we haven't broken anything in our latest test. In our latest set of changes. No, good. Okay, so we're still working. Everything still works the way it should. Okay. Okay, so we've now got functions within Python. Now then, functions within Bash are quite different beast. I won't bother doing Lua at the moment. Let's just do Bash. Okay, so right, so we're all working at the moment. Okay, functions within Bash. Now, these are a bit of a dog's breakfast, to be honest. Remember these positional variables. Okay, so $1 is the first entry on the command line. Well, functions within actually, let's just really. Okay. So we can do a very similar sort of thing. Functions within Bash are a bit of a mixed bag, really. Let's do a simple one. Let's do display greeting. Okay. Now, what you will note is that functions within Bash, I don't know why I bothered putting function in there because it's not really needed. Okay. So we define them simply by declaring them with the brackets after the name. Okay. And we don't have to indent, but pretty printing it, laying it out nicely makes it easier to see what's going on. Everything within these braces is a block of code. Now, to be clear, you can put these blocks of code anywhere. They don't have to actually be delimiting a function. They just define a set of instructions that are a unit. The display greeting brackets actually is the naming of that block of instructions. And this is where it starts to get a bit messed up, okay? Because this greeting message, okay, there's no clean way of naming parameters within a script. But if we do this, okay, we get a sort of close approximation. Okay, so what you've got here is you've got the greeting message is being assigned $1, which is a positional argument, remember, but it's not referring to the position of the argument on the command line of the script now, okay, but rather it's the position of the command on this command line. Okay, so when we invoke this and we give it the value we want to, oops, let's be tidy about it. Okay. Okay, so now what we've got is you'll notice that invoking a function within Bash is just like invoking a command on the command line, because that's basically what we're doing. Okay, so if I now run these checks again, okay, everything still checks out. Okay, so we've not changed what the program does, but we changed the way it does it. So just as if this were a command on the command line, the first entry, the first string on the command line will be assigned to the $1 within the scope of this function. Okay, so when you define a function, it's almost the same. Now, you might say to yourself, well, couldn't we just put, you know, a name in here? And the answer is no, that's just not the way it works. Okay, you can put stuff inside these brackets. You can, for example, put $1 to indicate that there is a variable there, but nobody ever does. Okay, so it's a bit shonky, but it is consistent. Okay, a function can be thought of just as another script. Okay, so it's a script within a script, as it were. Okay, so in just the same way as the script gets $1, $2, $3 passed in as the positional arguments on the command line, a function gets $1, $2 locally within its block. Okay, it gets $1, $2 locally within that block. Okay, and it's taken, or those values are assigned from the position on the command as it's invoked. So far, so good. Okay, so display greeting makes perfect sense. So now the next question, how do we get a value back from a function? Right, let's try writing compose message. Well, compose greeting, I think we called it in that one, didn't we? So we construct compose greeting. And we're going to do the same trick as before. So name is going to equal, remember, $1. Now, it would be nice, wouldn't it, if we could just say something like this. Return quotes hello, and then the name of our variable. And the exclamation. Oops. Okay, that would make perfect sense. Unfortunately, that's not the way the world works. Functions within Bash scripts, if you remember earlier, I said they operate much as a script within a script. Well, the only thing you can return from a script, the only value you can actually return from a script, okay, is a number, an integer. Okay? So traditionally, or by convention, 0 is a success. Any other number is considered to be an error message of some description. Now, the return statement can only return an integer. Right? However, there are ways of getting stuff back from functions, and there's an endless debate about how, which is the best. You can, for example, pass in a variable. So you can pass in one of the $1, $2s, or whatever can be the name of a variable, and you could use that. We won't use that method. The other way we can do it is we can just echo the value out. Okay? And you might think to yourself, hang on a minute. You can't just use echo, surely, because because if I just do echo like this, won't that print it out to the screen? And the answer is no. It will, kind of, but not really. Because it will do the compose greeting. Okay, I can do something like this: greeting message equal. And this is where things get really weird. Okay, I can do this. Compose greeting. All right. Let's try it and see what happens. Still works. Okay. So what's going on? Actually, while I'm at it, what I should have done. Okay. So what is this insanity? What's going on here? Right. This is going to take a while to explain. Okay. So compose greeting. Okay. It looks like echo should be outputting to the screen, but it doesn't. I told you a lie earlier. What it does is it outputs to a thing called the standard output stream. Okay. Standard output. And the standard output normally will then be printed out. If it's on a shell, okay, we print it out to the screen. So the standard output is, for all intents and purposes, at the top level, the console, the screen. But it's not really. It's actually a stream. Now, you don't need to worry about any of that. The upshot of it is that we can capture anything that the compose greeting function prints, in other words, directs to the standard output. We can capture it by putting it inside this $open brackets construct. So what this $open brackets construct means is it means invoke this command. Okay, bearing in mind that functions essentially are scripts within scripts, so it's a command. Invoke this command. Okay, whatever is put out to the standard output, I want you to just give me that back as the value. Okay, and I'll put it in quotes again so that we get the same issue with the quotes expansion. So it's a bit clunky, but it does what we need. Okay, so that is one way of getting values back from functions. If those values are strings, that's the simplest way. If it's more complicated than a string, then you have to use a different method. And this is where shell scripting becomes a bit funky, in all honesty, because you're using all these different ways of doing things. But that's the way it is. Okay, you will find yourself doing all sorts of contortions sometimes to sort of satisfy this this strangeness. I mean, another one is within a script, you might just have the convention. Okay, so you could have a convention like this. You could say, look, whenever a function exits, okay, whenever a function exits, we will say that the result variable will contain whatever the result variable will contain whatever it was, whatever we intended. Okay, so now so now what I can do is I can say call the function, and now all I have to do is use the result. Okay. Again, the script's still working, so that does the same thing. Okay, so now I'm taking advantage of the fact that result, I'm going to, any variable I define is, unless I tell it explicitly otherwise, is going to be global. I can actually tell it that this is a local variable, and really I should have done. Okay, so I can say, look, name is local to this function. I should really do the same thing with greeting message. By the way, this again, I'm putting these on separate lines. Okay, you could just put Okay, but that's considered to be more risky for a number of reasons. It's considered to be better form keep to keep the local declaration separate from the assignment. And that's true of a lot of languages. Okay, so yeah, so this name is now local. If I didn't do that, when I did this, name equals da da da, it would actually overwrite this name variable because it's referring to the same global, which in this program doesn't matter, but it would have mattered if I passed something else in. So yeah, so it's worth declaring your parameters as locals just to make sure that they are not stomping on stuff. So this result is actually global. So this composed greeting is actually setting that result, and then I'm using it. Okay, so that's another approach you can take to getting values back. Again, it's all a bit clunky, and there's a huge amount of debate over which is the better approach. Another way of doing it is to do things like I can do things like this. Oops. Let's call it value. Okay. And here, oops, got an error. Right. No, there's a way to do it. As you can see, it's not a way I commonly use. Okay. Identify what? Yep. When not found. Uh, Why is it trying to run it? I know there's a way, but you get the general idea. It's not a technique that I use. So I would advocate one of the other ways of doing it. Personally, I tend to use the echo one more than anything in this context. Because it reads it's more natural, I think, to do this. Within a script anyway. And the reason it's more natural is if you think about if you think about bash functions as just being, sort of scripts within scripts, then that's a much more natural way of interacting with them. Invoke it. The value returned is simply the printed output, which you can then use just as you would for a command. Okay, because you can put any command inside that $home package, it will work the same way. So it's more consistent. It gets a bit more complicated when you're dealing with things like returning more complicated data structures. But bash is really, if you start thinking in terms of more complicated data structures being passed as parameters, you probably want to be thinking about a different language, using Python, for example. Bash, you're not going to have a good time. So it's worth, it's just not worth the aggravation. Okay, so let's just make sure we're still on track. Nope, I've not fixed it. What have I done? Name. Hello, name. Oh, because I'm an idiot. And I've called compose message rather than. This is actually again a good teaching point. You wouldn't tend to make these kinds of mistakes in other languages. They would be picked up by the interpreter. Bash is not quite so forgiving. When we talk about there we go. When we talk about again, programming rather than coding. We'll get into that. Okay. Blimey, we've been doing a couple of hours. Right. There's only two more things I want to cover. Well, it's kind of one thing, but we'll call it two. And that is flow control from a coding point of view. So from a coding point of view, flow control basically comes down to two things, looping and conditional. So it's often the case that we want to do multiple things. And now I'm going to go off script a bit here because I know that I haven't written the exercise scripts for this. So we're not going to be running tests. But in here, okay, we've got this stuff. Let's say I wanted to display this greeting 3 times. Oh, actually, no. No, let's have a bit of fun. Okay, so I'm going to instead of taking the name from the command line, hash, by the way, starts a comment in bash scripts. Okay, so instead of doing this, what I'm going to do is I'm going to create a loop. Okay, and I'm going to say for name in And now what I can do is I can actually supply a list of names. Okay, so I can say Mark, Bill, and and a semicolon at the end of that. Then I say do, and the do just introduces the block of commands, and done ends it. So now you can see we get Mark, Bill, and world. So what's been going on? So this for loop basically says, I'm going to give you a space separated list of strings, and I want you to go through these one at a time and assign them to name, and then I want you to do whatever's in this do done block. Okay, so this is saying first assign name to be Mark, then I want you to compose the greeting message, and I want you to display it. Then I want you to assign Bill to be name, and then I want you to create a greeting message and display it. And finally, I want you to do world assigned to name. Okay. Another thing we could do is we could say, okay, we could say, right, instead of going for a loop, okay, we can do this. We can say things like, can we do a for loop again? Can we do a for loop or no? Let's do until. Okay, so we can say until count until until equal to 0. And here, here, now then, you might think we're on solid ground here, but oh, it's all unlucky. Okay. Yeah, we got a problem. Okay, and the problem is this. The count command has not been found, and that's because I am a fucking idiot. And I didn't put a dollar in front of it. Same problem here. Now the problem here is this. Line 20. Yeah, sorry, it's this. It's this line that's the problem, and that's because we can't do simple arithmetic like this. What we have to do is, oops, and now my brain starts to hurt because it's been a while since I did this. Yeah, okay, so we've figured out that problem. Still have a problem with there we go. EQ goes inside double. Anyway, right. So we've now got the loop going 3 times. Shows how much bash scripting I've done recently. Okay, so square brackets, simple test. The EQ, I seem to remember used inside the double square brackets. This is a different type of test, but anyway. So the until loop, again, is very simple because all it does is it says until this test, which is the thing in square brackets, is true, I want you to do whatever's inside the block. Okay, so again, we're preparing the message and displaying it, but that last little bit is saying, okay, I now want to do some arithmetic. Now, and this is why this sort of thing, Bash drives you fucking crazy with this kind of stuff. Inside brackets, right, and we've got count equals count minus 1, which looks exactly like arithmetic in any other language. We don't need the dollars. We don't need the dollar in the second count. Okay, because even though we're referring to count, because it's inside these 2 parentheses, 2 round brackets, Bash knows that it's a simple arithmetic expression, go figure. Right? We do need the dollar up here. Okay, because inside the test, we're doing, yeah, we want the value to be expanded. And in actual fact, the first time round, this would basically be 3 equals 0, which obviously is false. Okay, so that's looping. Right. So that's a couple of types of loop. Oops. Let's do a conditional. So, and say, so we can say if, and again we got these square brackets. So if name right, minus n. So if it's not an empty string, you've got to love Bash. I've got to admit, every time I try and do anything substantial with, I end up having to read the bloody map and look everything up, because it's just, yeah, it's full of all these little idiosyncrasies. Okay, so unless you're doing this shit all day, every day, it can be a bit of a nightmare. Which is why, generally speaking, personally, if my Bash scripts start to get complicated, I'll move over to something like Python, or if I think it's going to be complicated, I'll write it in Python. Sometimes, just because I feel like flagellating myself, I will do something in Bash that I know it's not really designed for. But generally speaking, if your script is going to be more than a few dozen lines, you really want to be looking at a different language. If you're going to use any kind of complicated data structures, use a proper scripting language. Bash is great for doing small things or very straightforward things. It's really not a programming language for doing complex systems. I mean, there are people that will disagree, and I have read some Bash scripts that have done some pretty complicated stuff. But unless you're doing it day in, day out, it's not worth the effort. And invariably, you end up having to do some pretty shonky stuff, to get Bash to do what you want. That would be trivial in almost any, higher level language. Okay, so what's this saying? This is saying if the name I supply is blank, in other words, if that quote, if this name variable expands to nothing, in other words, that is an empty string, then I don't want this statement to run. In other words, this minus n, which basically says if this next string is not empty, then this evaluates to true. If this expression evaluates to true, then we do what's inside it. So the upshot of all of that is, if I call this with a name, it will. Oh, I forgot to change do to then. Okay, so if I supply it with a name, I get what I expect. If I supply it without a name, it does nothing. Now, we can be a bit nicer, okay, and we can say else. Go. Not particularly helpful, okay, but at least it gives me a clue as to what I've. Okay, so the else statement is run if this test evaluates to false, then this part will be run. Now, there's one other thing that you might want to, well, there are loads of other conditionals. There are things like the case statement, which allows us to use pattern matching on a variable. There's the else if, or the elif clause on these things. It doesn't make sense in this context, but you can do things like this, elif, and then another test here. Okay, basically you can have another test. So if the first test is false, then it will run the second test. If the second test is false, then it will go to the else clause. I don't want to go into too much detail. Anyway, long and the short of it, you can do all of this stuff with let's make sure we haven't broken anything. Let's just run. Can't remember. Okay, so we're back to it. Okay, so that was conditionals and looping in Bash, and you've got similar kind of structures in Python. Okay, so in here we can do things like if name is empty. In Python. Oh, actually, there's a bug. And if we were programming, we would now write a test for that. Yeah, there's a bug. The bug is this. That first element will only exist if it's actually on the command line. So that's interesting, actually. Why didn't... Oh, I know why. It's because when I wrote the test, I cheated. Because what I wrote was this. Okay, so that will work fine. Because we do have a first command line argument. Now there, we do not have a first line command line. Okay, so in this case, the first command line argument is the empty string. In this case, there is no first command line argument, so we get that error. Okay, so we would need to do a test. We would need to test how many entries were in argv. Okay, and if there was only one entry, i.e. the 0th entry, then name is basically the empty string. In fact, if I look at the test, you can see that's exactly how I cheat. That double quote there says pass in the empty string to the command rather than pass nothing. So anyway, that's nicety. And very quickly, I'll go through all of this in more detail again. Very quickly, you've got similar kind of structures. You've got like for loops, until loops, while loops, like to do looping. I'm sorry, I'm getting tired. Right, I'm going to call it a night, and we'll come back to this another day. Just get looping here. Leave this in a fit state. Yeah, good. Right. Again, good habit to get into. At the end of the day, make sure all your tests are passing. Well, having said that, I guess if you're working in a sort of TDD style, leaving a test broken at the end of the day, that is not the end of the world, because that's your to-do list for the following day. But right, anyway, right, that's it. Like I said, I'm knackered. I'm going to bed. Thanks to those of you that hung around, and yeah, hopefully that's been of some use. I think the next one I do on programming, which I might do next week, we'll pick up and we'll do something a bit more sophisticated with this. We'll start looking at things like how to write the tests, although that's fairly advanced. And to simplify things, I might, unless I've got a compelling reason to, I might stick to just writing the code in Python. And yeah, unless I've got a compelling reason to switch between them. I'm not sure what I'm going to do in the book. I might switch freely between them in the book, but we'll see. Right, that's it. I'm done.